Hello students, today we are going to start the lesson number 9, moving ahead with the basic 256. In the previous class we have learned about the programming language basic 256 as one of the beginners computer languages used to teach the programming concepts to the young programmers. We use some of the basic programming commands like C, print, CLS, REM, input, etc. for writing the computer programs. We also learn to store the data values of our program which are to be processed. We will now learn about creating the memory variables and also about the non-sequential execution of the program using the control statements. Let's move on to the introduction. The data values which are processed by the basic 256 program are needed to be stored in the main memory of the computer system. The values can be stored as fixed values or changeable values. The values can be the numeric or string of characters. Let us now learn to create and use the memory locations to store such different types of data values in our program. Constants. As the name suggests, these are the data values which remain same throughout till the end of the program. That is, they remain fixed like your name, date of birth, blood group, etc. To store such data values, constant type of memory locations are created. Constants can be of different types like first, numeric constant and second, string constant. Numeric constant. All type of number values like integer, real, natural numbers, etc. which express fixed information forms the numeric constant. Example 20, minus 30, 17.4, minus 18.9, etc. String constants. These are the fixed values stored in the form of letters, numbers or symbols. They can be represented in the double quotes. Example, computer in double quotes. If you are writing the numeric A125, it should be also in double quotes. 12.75 double quotes, 7 days in double quotes, etc. Variables. Variables are the type of memory location whose value can be changed during the program execution. Example, age, weight, height, class, etc. Just like constant variables are also of different types like numeric variables and string variables. First, numeric variable. This type of variables can store only number values which can be used for any type of calculation. These can be integer or real values. Now, string variables. In this type of variables we can store alphanumeric values. Those values are always enclosed in double quotes. String values are represented with a name followed by the $sign. For example, name $. Now name will be in the double quotes. If the name is Ronit, then Ronit will be written in double quotes. Some of the rules for naming variables are: it always starts with a letter. It should not be a keyword. Basic 256 commands. You know now basic 256 commands, that is CLS, RAM, etc. No blank space is allowed. Special characters except $, percentage and hash are not allowed. Variable names are case sensitive. That is, the names capital N with name $, or it can be whole capital name with a $sign, are the two different variables. Operators. Operators are the symbols which tell the type of operations to be performed on the data values. Every programming language has mathematical, relational and logical operators. Let us discuss one by one. First is mathematical operator. Mathematical operators are used between the numeric data values to form mathematical expressions. For example, 2 plus 4 or 4 into 3 plus 7, etc. Various mathematical operators are plus sign with additional operator. It can be a plus b, minus subtraction operator a minus b, multiplication operator a into b, division operator a divided by b, exponential operator a exponent b, and percentage modulus remainder operator a percentage b. Now, relational operators. These operators are used for comparing the two values and the result is always in the form of true or false. Relational operators can be used in basic 256R. First, equal to. We can write 4 equal to 4. Yes, it is true. Second is greater than. 5 is greater than 6. No, it's an false. Less than. 6 less than 7. Yes, it's true. Greater than equal to. We can write 5 greater than equal to 4. Yes, it is true. Less than equal to. 5 less than equal to 5. It's true. Not equal to. 6 greater than or less than 7. That's the true. Logical operators. These operators are used to check the multiple conditions. Various logical operators are and to check if both the conditions are true. A greater than 4 and B greater than C. Second condition is OR to check if one of the condition is true. A greater than 4 or B greater than 6. Third, NOT to check for opposite result. Not A greater than 4. Rules transfer statements. Doing simple tasks is easy as the steps involved are in a particular sequence. Just as you follow a normal routine in the morning, like wake up in the morning, get ready for school, have your breakfast, board your school bus, and reach the school. This is the simple sequence of actions, but if it becomes complex, example, your school bus is missed, then you need an alternative for going to school. The routine becomes non-sequential. Non-sequential action depends upon the conditions, whether your school bus comes or not, whether your father will drop you to school or your friend picks you up. It is easy for us to decide accordingly. But how do we make the computer to check the condition and decide? Basic 256 provides relational operators and statements to check the conditions. Till now, you have learned the programming in which execution takes place one by one in sequential order. The program is said to be non-sequential if the statements present in it are executed in a sequence. The control of a program shifts from one statement to any other specific statement and alters the order of execution. These are called control transfer operation. If, then, and if statement. This is one of the powerful basic 256 statements which evaluates the condition to true or for executing the statements between then and if. The syntax for writing the statement is as follows. If condition then statements to be executed if condition tested true and if the condition specified stands true, the statement enclosed between then and if will be executed, otherwise not. Let us understand this concept with the help of basic 256 program, which reads a number and checks whether if it is greater than 100 or not. CLS input enter number A. If A greater than 100, then print number is greater than 100, and if print thanks for using this program. And in the above program, if the number is greater than 100, it prints number is greater than 100, and then thanks for using this program. Whereas if the number is less than 100 or equal to 100, then it prints only thanks for giving this using this program. This means if the condition in if clause is true, it runs the statement written within if, and if else, it skips this statement. If then else statement. In the above example, there is only true block, and if condition is false, then no separate message is displayed. If you want to display another message numbers less than or equal to 100, then you can use else clause within its statement. Syntax: if condition then statement block 1 else statement block 2 and if. Let's modify the above program by adding else clause in it. CLS input the number A. If A is greater than 100, print number is greater than 100. Else int number is less than or equal to 100, and if print thanks for using this program. And now when you run the program, the output will be something like this. In case when you entered a number is greater than 100, the output statement will be number is greater than 100 and thanks for using this program. This is because when the condition stands true, the statements which appear between then and else are executed, which is also known as true block of if statement. After that, it continues with the statements after and if clause. Whereas when the value is less than 100, the statement in the true block are skipped, and in the false block, that is after else clause, are executed. Let's take some more examples of this statement. Program to find the largest among the two numbers. RAM to find larger among the two. CLS enter the first number A, input, enter the second number B. If A is greater than B, then print number plus A is greater, else print number plus B plus is greater. And if and. Now in the output, enter the first number 56, enter the second number 67. Number 67 is greater. Program to check whether a number is even or odd. RAM to check even or odd number. CLS input enter the number A. If A % 2 equals to 0, then print number is even, else print number is odd. And if and. The output enter the number 45 and number is odd. Go to statement. This is an unconditional control transfer statement which shifts the control to a specific label without testing any condition check. Go to command is as follows. Syntax: go to label. In the following program, start hash label. Start hash. Print hello world in the two inverted commas. Go to start. Then end. In the program, statement number 1 represents a label start, whereas the statement number 3 is an unconditional transfer statement which shifts the control to the label start. So the output of the above program will be infinite display of hello world in the output screen. This is because the third line of the program transfers the control back to line number 1 and starts the execution from there. So to stop the unending process, your need to press stop button on the toolbar. Looping statements. Many a time it becomes important to repeat a particular set of statements in a program for a certain number of times or till a condition is met. Such repetitions are carried out with the help of looping constructs. So, loops are the control structures which repeat a set of statements for a specific number of times. Basic 256 provides a variety of looping control structures which can be used according to the need of our program. These are for, next, while, and while, do, until. For next statement. For next looping structure instructs the computer to repeat enclosed a set of statements for a specific number of times. It needs a counter variable which keeps a track of the number of times a process has to be repeated. The syntax of the looping structure is for counter variable equals to initial value to final value. Set of statements to be repeated, next counter variable. Let us understand this loop with the help of an example which prints 10 natural numbers on our output screen. CLS for I equals to 1 to 10, print I, next I. Now the output of the above program will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In the above program, variable I is used as a counter variable. Initially, it stores the value in it. The value of in this variable is checked with the final value, which is 10 in this case. It is found to be less than or equal to the final value. The statements in the loop body are executed. When the last instruction of this structure, that is next I, encounters the value present in the counter variable is incremented by 1 and the control comes back to the for statement. This process continues till the value in the counter variable exceeds the final value, and after that it becomes out of the looping structure to execute the rest of the instructions in the program. Step clause in for next loop. Now as you know that next clause increments the counter variable by 1 every time. But if you want to increment the counter variable by some other number, or you have to decrement the value in the counter variable, then you can use step clause in for next loop as. For counter variable equals to initial value to final value step n. Set of statements to be repeated. Next, counter variable. In this case, n is the value by which the counter variable will get incremented or decremented after each iteration. Now let us take another example. If you want to print all odd numbers between 1 to 20, then the program will be CLS for I equals to 1 to 20 step 2, print I and next I. Then in the above program will produce the following output when executed is 1, 3, 5, 7, 9, 11, 13, 15, 17, 19. While and while loop. This is another type of looping structure in basic 256. In case for next loop, the statements are executed for a particular number of times, whereas while and while loop execute as long as the condition stated in it as true. The syntax of while and while loop is while condition, statements of the loop, and while. Let us try to understand the working of while and while loop with the help of following program. CLS I equals to 1 while I less than equal to 10. Input enter the name and dollar, print welcome plus and dollar. I equals to I plus 1 and while. In this program, I is the counter variable which stores the value 1 in the beginning and in the next statement with the beginning of while loop. Value of the variable is checked against the condition. that is I less than equal to 10. As the value of I is less than 10, the three statements in the loop will be executed. And in the last statement, counter variable is incremented by 1. As the end while statement is encountered, the counter is handed over to while statement again. When the value of I exceeds 10, the condition specified will fail, causing the termination of loop, and rest of the statements in the program are executed. Now here are the more examples of while and while loop. Program that accepts a number till the user enters and print the sum of numbers. CLS sum equals to 0, CH dollar equals to Y, while CH dollar equals to in the double quotes Y. Input in the double quotes enter the number, comma, and sum equals to sum plus and input in the two double inverted quotes. Do you want to enter more numbers? Semicolon CH dollars, and while print in the two double inverted quotes sum of all your numbers is equal to, and the output will be enter the number 67. Do you want to enter the more number? Yes. Enter the number 70. Do you want to enter the more numbers? Yes. Sum of your all numbers is equals to 145. In do until loop is enclosed. Do until loop. In do until loop, the enclosed statements are executed till the condition specified stands false. As soon as the condition becomes true, control comes out of the looping instruct. Unlike while loop, in this the condition is tested at the end of looping block. So it is also called as an exit control loop. The syntax to use this construct is do statements to be executed until condition. Now the program. Printing all the even numbers between 1 to 20. CLS equals to 0. Do sum equals to sum plus 2. Print sum until sum greater than equal to 20. Now the text output will be 2, 4, 6, 8, 10, 12, 14, 16, 18 and 20. Now we are going to do some programs. First, write a program to accept the marks for 3 subjects to calculate an average mark of 3 subjects and the display first division if it is greater than 90, second division if it is greater than 60 but less than 90, otherwise display the third division. CLS sum equals to 0, average equals to 0, input enter marks in English into double inverted quotes, comma A, input enter the marks in maths in double quotes, comma B, input enter the marks in science in two double quotes, comma C, print equals to A plus B plus C, sum equals to A plus B plus C. Now print total marks in two double quotes plus sum, average equals to sum divided by 3. Print into double inverted quotes average plus ABG. If average is greater than 90, then print into double inverted quotes first division, else if average is greater than equals to 60 and average is less than equals to 90, then print the second division, else print the third division, and if and now the text output, if we enter the marks in English 90, enter the marks in math 60, enter the marks in science 90, total marks equals to 240, average equals to 80 and second division. Now we will do this another program. Write a program to check whether the given number is positive, negative or 0. CLS input and double inverted quotes enter a number comma a. If a is greater than 0, then print into double inverted quotes positive, else a is less than 0, then print negative, else print 0, and if. Now the text output will be enter a number 0 when the output will be 0. Now the third program we are going to do is write a program to input age from the user. If age is greater than equal to 18, then display a message in double quotes eligible to vote, otherwise not eligible. CLF input in double inverted quotes enter your age. If age is greater than equals to 18, then print into double quotes eligible to vote, else print not eligible, and if. Now the text output will be enter your age 18. Now it is eligible to vote. Now the fourth, write a program to display multiples of 6 less than 50. We are going to write the program. CLF for I equals to 6 to 50, step 6. Print multiples of 6 colon in double inverted quotes plus I. Next I and. Now the text output will be, because we have written we want up to 50, so the text output is multiple of 6, 1 for 6, then 12, 6 to 12, 6 3 18, 6 4 24, 6 5 30, 6 6 36, 6 7 42, and 6 8. This is the output of multiples of 6 which is less than 50. Now if you want up to 60, so you can write for I equals to 6 to 60. Okay, I hope now you have understood this chapter. Thank you for watching this video.